governing the behavior of matter and energy. Someone is having the mic on, please. Mute your mics, do as wise. Yeah, so let me repeat. So physics is the most fundamental natural science concerned with basic principles governing the behavior of matter and energy. So as you have seen, I've marked most fundamental natural science. What does this mean? It means most of the sciences, physics is the foundation. You get? When you talk of chemistry, you get? In chemistry, you look at atoms. Before you look at atoms, you need to understand that there is physics, you get, that can make you understand atoms. Because without physics, you can't understand those atoms. So there are principles, you get, that comes from physics, which I want you to understand. Apart from that, if you want to understand biology, you get, you want to understand maybe the blood pressure, the flow of blood, you need to understand that um, there are laws or principles of physics that are used in biology. You get? We have pressure. We have so many things that can help us to understand the pressure of blood. You get? Apart from that, physics is very helpful for you to understand the electrical impulse, the nerve impulse. I'm sure you learned about the nerves in biology. I'm sure you're able to remember the nerves. How a nerve is able to conduct electrical impulse and transmit any information from one place to the other, from the receptor to the central nervous system, and then to the effector. What? Physics. The chemical bonding, it's because of physics. In biology, I've talked about how physics is important to make you understand the nerve impulse, the nerve, how the nerve impulse is conducted to transmit what information. It's using electrical signals. Those electrical signals, that's physics that is there. You get. Apart from that, how blood is pumped. You get inside the body. There is a part of physics that explains that. Hope that is clear. So, are you now clear on what I mean? Physics is the most fundamental natural science. Thank you so much. And then physics is concerned with what? Basic principles. So there are principles. Physics is full of principles. So there are principles governing the behavior of matter and what? Energy. You know matter how it is. So there are principles that makes you to understand matter. And all this is because of physics. So physics is all about principles that will make you understand matter and energy. So we'll look at that. So now, what else are you supposed to know? What's the aim for physics? Since you want to know what physics is all about now, what's the aim? Because you need to have the aim of whatever you are learning. So what's the aim? So there are so many things that you need to understand. But the first thing that I want you to know is the aim is to discover universal laws. So physics it aims to discover universal laws, laws that can be applied everywhere, not just in Zambia, not just in other countries, but universal. For example, there are laws which are universal, like Newton's law of what? Um, Motion. That law. Is it just applied um, maybe to the whites? It's also applied everywhere, not so. Hello? A- Are you able to get me? Have you understood this concept? Yes. So what do I mean when I say physics aims to discover universal laws? So it will help you to come up with, when you come up with a law, or let me just say this, these scientists, they came up with laws, and those laws are applied everywhere. You get? So we have laws that are applied everywhere, not just to the whites, but we are using them here, like Newton's law of what? Motion. It is used also here. It's a universal law. All the people that are doing physics, they use those laws. Is it clear now? Should I proceed to the other M? Thank you so much. So let me go to the other part now. So apart from that, we need to understand that physics also express these laws in mathematical what? Form. Express these same laws, you get? Like Newton's law of motion, it's expressed in mathematical form. That's why in physics, It's full of solving. You'll be solving now using the same laws. You get? So laws will just help you to explain what the relationship that is happening with something, with nature. You get? So now, for example, let me do this to make you understand this thing. For example, you know that Newton's law of motion. Who can remember Newton's second law of motion? Who can remember Newton's law second of motion? The formula. So it's force is equal to what? Mass multiplied by what? Acceleration. So have you seen? Once the law is discovered, physics also helps to express these same laws. You get? The discovered laws in mathematical form. You get? So it will make you understand what's happening now in nature. So, for example, these laws are used by engineers around the world. These laws are used by engineers around the what? The world. For example, if they want to build something, you get, they will see to say this force, the force which is at this place, is it greater than the mass of this object which we are trying to maybe set on this or build? Have you seen? So if the mass, what will happen if the mass is less? If the mass is less, let me do this. If the mass is less, decreasing, and the force is what? Greater. What will happen? It will reach to what? Acceleration. You get? So you understand that this law helps scientists um to come up with to know or to know if in structures like in building structures, this can help to say if we're trying to build something, the mass of an object is less, the force is greater, so it can lead to acceleration. Therefore, this structure can't be suitable here. You get? So if at all you increase the mass, what will happen if the mass is increased, like it's having greater mass, the less is force? Then they can conclude to say, we can come up with the building here because the force which is here is not greater than the mass. The mass is greater, so therefore there will be no acceleration. So the greater force, if the force is greater than the mass, it leads to acceleration. So these laws are used, you get, and they are used in constructions, you get. Is it clear on this part before I proceed? So what happens if the mass is less and the force is greater? Hello? What happens if the mass is less and the force is greater? Imagine, do you know what makes you to push that car? It's because of the applying force you're applying is greater. That's what makes the car to move when you're pushing it. You get? Than the mass of that. Like you're applying a greater force and the mass is less. But if the mass is greater, will the car move if the force is less? No. So this this helps you to understand something in physics. You get? Now, let's go to the other one. So now, since now we're talking about universal laws, after that, laws are expressed in mathematical form. Apart from that, these same laws are applied, apply them to explain natural phenomena, you get? To explain what's happening in the natural, you get? The phenomena. A phenomena can be anything in nature. It can be magnetism, it can be light, it can be thunder, it can be the rainbow. You get? So there are laws, and those laws should be expressed in mathematical form to and applied to explain the natural phenomena, what's happening around us. So laws helps to explain what's happening around us. You get? Like the force, mass, and acceleration, the relationship which is there. It is used by engineers all around the world to come up with proper structures. You get? They need to determine the forces that are around the environment before they build anything, before they come up with anything. You get? So that's what you need to know. Apart from that, you need to know that, example, the motion of planets. Have you seen the importance of the same laws? They help you to understand the motion of planets. Apart from that, the laws will help you understand the vibration of what? Atoms, how atoms are vibrating. It's because of the laws, this same one. They will make you understand what's happening. And then apart from that, this the same laws will help you understand the flow of electricity. You get? Or I explained using the what? The physics laws applied at different what scales. So the physics laws are very much important because they help you understand the vibration of atoms, the flow of electricity, and the motion of planets. So before I proceed to any other part, is this first part clear? Are you able to understand that physics is all about discovering laws, expressing the laws in mathematical form? Why are laws expressed in mathematical form? So that it can help you to understand what's happening there, phenomena in nature. You get? Is it clear before I proceed to the other part? Thank you so much. So now, let's look at the general discussion of physics. General discussion of physics. So now, physics, what do you have to know about physics? The discussion. So physics is based on what? Experiments and observations. Physics is based on experiments and observations. For you to come up with a law, like Newton's law of motion, do you know what was the first thing that came into his mind? He observed something. You get? He observed something. After observing, now there were some experiments that were conducted to prove whatever he observed. You get? So physics is based on what? Experiments and observations. So physics is not something that should be guesswork. No. Hope that is clear. So physics should be based on what? Observations. Also, there is that gravitational law of falling objects. You get? You throw a stone up, it comes down. So there was a scientist, he observed what was happening. And then after that, there was some experiment conducted. So physics is based on experiment and what? Observations. Hope that is clear. Apart from that, it uses mathematics as its language. It's full of calculations. From talking about the Newton's law of motion there, it's which is expressed in mathematical form. You get? So its language, it uses mathematics as what? Its language. Hope that is clear. Apart from that, it helps develop models. You get? It helps to develop models. What do you understand by a model? It helps to develop models to simplify complex what? Systems. So have you seen this is a complex system, something which is complex. And then physics will help you to come up with what? The model. So a model is just a simplified representation. You get? Um, to help you understand the phenomena or what's happening. You get? To help you understand or simplify the complex what? System. So you come up with a simplified way of understanding this. You get? Like even just the same law. You get? I'll help you. I'll make you understand. So I'll make you understand about the model. Don't worry. So it's developed models to simplify complex system. I'm sure you are able to understand. So a model is just a simplified explanation that will make you understand something which is complex, something which is so confusing, or you're about, oh, okay, this is something big, but physics will help you to come up with model, simplified explanation about something. Hope that is clear. And then I'll make you understand if you're not clear about the model. Then from that, let's go now to physics progresses by. What makes physics to progress? As we said, physics is full of what? Laws, theories. Now, for you to come up with a law or a theory, something must be done. Even these scientists who came up with laws and theories, as we said, physics is based on experimental observation. What should be the first thing? And they can even ask you this. Physics progresses by what? So it progresses by four things that I want you to know. Four things that makes physics to progress. The first one is observation. So it must start with you notice something around you. You can notice anything around nature. You get around the nature. Is it about magnetism? Is it about the rainbow? You observe. After observing, something must be done. So it starts with an observation. So for any law or any theory to be there, it started with an observation. That's the first step. Apart from that, the hypothesis now comes in. The hypothesis comes in now. So now, since you observed something, you come up with a study, you see something, and you come up with questions. Say, okay, why is this happening like this? Now, the second thing is the hypothesis. Tested hypothesis, just tested explanations. You get tested explanations to help you explain what you observed. Tested explanations to help you explain what you observed. You get? So you know that you came up with something you observed, like Newton's law of motion. You observed something. Now he came up with tested explanations so that he can defend whatever you observed. And so you get. So you need to ensure that you come up with tested what explanations to help you defend the observation, what you observed. You get. So that's a hypothesis. And then apart from that, um, there must be an experiment. Yes, the hypothesis is there whereby you have the tested explanation about whatever you came up with. Now there must be an experiment. So an experiment is there just the repeated tests to check whether the hypothesis, something that you observed, is what true or not. You get? So there must be what an experiment, and the experiment is just the repeated tests that are carried out. You get? They are carried out so that to check if the hypothesis is what uh, correct or wrong. So if the hypothesis is wrong, then the law won't be formed. If the experiment fails, like it fails to prove the hypothesis, then there will be no law, there will be no theory that will be what formed. You get? And then if the experiment is supporting the hypothesis, what will happen? The theory or law will be formed. You get? So have you seen the steps that makes physics to progress? These are the four things that you need to know. So for a law to be formed now, there must be an observation, as I said, the hypothesis, experiment. If the experiment is not successful, then you won't progress to the theory or law. Then it will be rejected. So there are so many laws and theories that have been rejected by some other scientists. And then now, what do you understand by the theory now? Let me start with a law, as we said. So what's a law? So a law describes what happens in nature. Yes, a law just helps you to describe what happens in nature. So Newton's law of motion just helps us to describe what happens in nature, relationships that is on force, mass, and what acceleration. Now, this one is based on what? Is based on what? So the law, as we said, it just helps you to understand or to describe what happens in nature, mostly through it just helps you to explain what's happening. And then let's go to the theory. What do you understand by the theory? So the theory is just something that helps you to understand why. Why is it happening? Why is this law happening? Why is this law happening? So, have you seen what's happening? So, the law is helping you to describe what's happening, just describing what's happening. Now, the theory is therefore to support why it's happening. Theory is therefore to help you to understand why it's happening. A law just what's just helps you to describe what's happening. Hope that is clear. So is this part clear? Are you guys clear on all the parts before I proceed to the other part? Huh? So you now understand you now understand you now understand the hypothesis, the experiment, and the theory, what happens for a law to be approved or not? Okay, thank you so much. Let me progress. Thank you so much. Now let's go to okay, yeah, you can ask. Okay, okay, okay. Okay, let's progress now. So, relationships of physics to other fields. So now, other fields. Let's look at other fields of which I tackled it. So, relationship. So don't worry. So now, physics forms the foundation of all natural sciences, as I said. Physics forms the foundation of all natural sciences. So now, let's start with chemistry. Chemistry. So in chemistry, we have quantum mechanics. Quantum mechanics. It helps you to explain the atomic bonding. Someone is having the mic on. Please mute first. Have you seen the application or the relationship of physics with other sciences? So physics is helps us. to understand, it helps you to understand some parts of chemistry, and that part of chemistry is the atomic bonding. You get? So quantum mechanics. This is physics. You get? That helps to explain the atomic what bonding. You get? So without physics, it's very hard um, for you to understand some concepts in chemistry. You get? So physics without chemistry without physics, it can just be something of memory without knowing where it's coming from. You get? So there are theories. A theory will help you understand why something is happening. So in chemistry, you understood bonding, or because of what? Physics. You get? Because of quantum physics, which helps to explain the atomic what? Bonding. So as you can see, these are just atoms around the what? The nucleus. You get? We're understanding this all because of what? Quantum physics. So as I said, chemistry without physics, it can be just something of memory, just um, having some, you just having some memory. You're not even sure of whatever is happening, but we're able to understand what happens in atomic bonding, all because of what? Quantum physics. Hope that is clear. And you know what governs the atomic bonding? The electrical forces. Those electrical forces that makes atoms to attract each other. It's because of what? You understand? Because of what? Electrical forces. Because of what? Quantum what? Physics. Hope that is clear. So I can proceed on this part. So that's the first one. As we can see, we are trying to look at the applications or the relationship of physics to other fields, how physics is applied in other fields. So in chemistry, I've talked about quantum physics. Now let's look at the other one. So now, what about in biology? In biology, what's the relationship of physics to other fields? Like in biology, what how does it help? So in biology, physics explains nerve impulses and blood flow. As you can see, nerve impulse. I'm sure you learned about nerve impulse. So because of physics, we're able to understand the nerve impulse. The nerve impulse, how is the nerve impulse generated? When someone touches you, how is that nerve impulse generated? So there are electrical. I can hear people. I can hear someone there. So physics helps you to understand. Someone is having the mic on. Please switch off your mics. So as I said, physics explains nerve impulses. So for you to respond or to the external environment, there are nerves around the body. Now, how is that nerve impulse generated? There are electrical signals. Those electrical signals, that's physics. Have you seen? And it's applied in biology. So have you seen the relationship of physics in other fields? We're able to understand the nervous system. The nervous system is full of nerves that conduct electrical impulses in order to transmit that impulse from the near skin, the surrounding skin, the receptor to the what? The brain. You get? Because of the electrical impulse. And then let's go to the blood flow. So blood flow also is explained by what? Physics under fluid mechanics. There's a part called fluid mechanics that explains blood flow. You get? And because of that, physics has come up with a law. It is applied in biology. You get? So physics is very much important to help you understand. So as I said, we have this. As you can see, this is a new law. Now, for us to conduct an electrical impulse, there must be what? Electrical signals that are generated. Yes? When you touch someone, there's an electrical generated. Then you transmit that information from the receptor near your skin to the brain. You get? So that conducting of that electrical signals is that's what? Physics. Hope that is clear. Yes. So nerve impulse, we're able to know nerve impulse to start nerve impulse in biology, or because of physics, because of electrical what? Impulse. Electrical impulse, that's physics. Blood flow, I've talked about it. So as you can see, this is a blood flow. How blood is pumped. It's because of fluid mechanics, the component of physics that helps you to understand the blood flow, how blood flows around the what? The body. From that, Let's look at the other application in medicine. In medicine, I'm sure you guys you haven't forgotten this. So in medicine, we have M, M, MRI and X-rays. So, but for you, you are familiar with the X-rays, so I'll focus much on the X-rays. So MRI and X-rays are apply are applications of what? Electromagnetism. As you can see, electromagnetism here, which is electricity and magnetism. This is physics. You get? So now, these X-rays, if you can remember, they work under this same under the principle of electromagnetism. For example, if you remember radioactivity, what happens in radioactivity? Gamma ray has high penetrating power. We have gamma ray, X-rays, and these are used in hospitals for doctors to come up with diagnosis. For doctors to come up with diagnosis to know your condition, or maybe you present with you tell the doctor to say you're having a fracture, or because of maybe you suspect that you're having a fracture because of maybe due to accident or what. They can't do anything not until um, they diagnose, they try to know or to find out the cause. That's when they can put you under treatment, you get? So it's helpful. So physics is very much important. So as you can see in hospitals, these X-rays, they're able to see what's inside your body or your bones, all because of the principle or the application of what? Electromagnetism. This component of what? Physics. You get? So as you can see, X-rays, they penetrate your skin. They will penetrate through your skin and they will capture where the fracture is in case you're having a fracture. So physics is very much important even in this modern world. As you can see in hospitals, there are diagnostic appliances like machineries that helps to discover conditions, to know if someone has a certain problem or condition. You get? So physics is very much important. It's applied also in medicine. You get? So as some of the diagnostic machines, they work with electromagnetism. Hope that is clear. Now let's proceed to engineering. So as you can see, physics is very much important in engineering. So for those who want to become engineers, physics is your thing, and I'm here to make physics simple for you. So now, in mechanics and thermodynamics, so as you can see, this picture will just help you to understand. So in mechanics, so mechanics just helps you to design. We have mechanical engineers. They help in terms of design. You get? Designing structures, designing and analyzing structures. Thermodynamics is just here, therefore, to help you understand um, conservation of energy and heat energy. As you can see, even in these cables, as energy is being transferred or power is being transferred from one place to the other, you can notice that there's some heat which is lost, not so. Eddy current. If I told you learned about eddy current in your grade 12, if you remember under transformer, you get? So this thing is also applied everywhere, you get? So it's very much important. So these engineers here, they can even try to design um, structures or design even this power grid. You're able to see they design things and everything like that. Not only that, they can notice maybe problems if they are so how power is being transferred in the energy, if at all it's okay, or maybe there is what's making maybe power from the where it's being generated, like from the power house where it's being generated, but what's making power not to reach in houses, like if it's generated at maybe the power which is released from where it's being generated to homes, maybe you find that it's not according to the expected. Maybe you're having you're experiencing maybe problems whereby you're not having enough power. Maybe the lights are not lighting according. It's because of maybe there are some problems in the cables and everything like that. So engineers are there for to analyze and to come up with solutions. You get? So this helps in power systems. You get? So that's the importance of physics. So physics is very much important. It helps to design structures and to solve problems around us. You get? Hope that is clear. Now let's go to nature of physics. What do you understand by nature of physics? So just how physics or nature of science. Sorry, what do you have to know about nature of science? So you need to know that nature of science should be empirical. Empirical means based on what? Experiments. It should be based on what? Experiments, as I've talked about it. So nature of science is based on what? Experiments. Apart from that, it must be predictive. Predictive allows predictions of outcomes. Like for those who study weather forecast, you get how are they able to come up with some predictions to say it won't rain, or maybe after 5 years we experience lunar eclipse? It's because of nature of science or physics itself. Nature is predictive. You get, and then the other one I've talked about, it's empirical, which means based on what? Experiments. Apart from that, it's self-correcting. Self-correcting. So theories change with what? New evidence. So you can disapprove some theories. If at all, you can come up with an observation. Apart from that observation, you come up with repeated explanation, which is an hypothesis. After that, there must be an experiment to check if that's okay. After they check, so we have seen some theories being cancelled. You get? Someone came up with a law. After some time, it has been changed, or because of they discovered to say it's not matching and it's not true. You get? So self-correcting. Hope that is clear. So not scientific knowledge is not absolute truth, but the best explanation supported by evidence. It must be supported by evidence. Now let's go to models, theories, and laws. So here I want you to understand now what's a model. What's a model now? So a model is a simplified representation used to explain observations. Have you seen? So when you come up with something, you notice something, you can come up with a model, which is a simplified presentation that can help you explain the observation. You get? So we have some models of which I'll give an example, which you have to know. So an example of a model is particle model of matter. Particle model of matter, which is this. I'm sure when you see this, you'll be able to remember this at your grade 12. Unless if you used to dodge, but if you used to attend classes and used to study, I'm sure you can relate with whatever you're seeing here. So this is just a model. So this is just a simplified explanation that can help you understand uh, something that someone observed. You get? So as you can see, here we are having some particles, some number of particles. Here we're having particles, here you're having particles. But as you can see, here, as you increase temperature, what's happening? As you increase temperature, the particles say, so from solid to liquid, it has changed. Have you seen? So, and then this process, what process is happening there? From solid to liquid. How many can remember this? What do we call that state? From solid to liquid? Very good. So have you seen? You're able to understand um, melting all because of a model. All because of a model, we're able to understand. So a model is just a simplified representation used to explain observations. Okay. So a certain scientist had to observe this, and then he came up with a model that will make people to understand a simplified way, in a simplified way. You get? So I'm sure you are clear on this part. I don't have to take time. Let's go to a theory. Now, what do you understand by a theory? We need to know a theory. So a theory now is a comprehensive explanation. Now, comprehensive, you can't compare with a model which is simplified. Comprehensive, it's having enough data. You need to take time. Comprehensive explanation supported by repeated experiments. Have you seen? A theory is supported by repeated experiments. A theory is supported by repeated experiments. That's why it has comprehensive explanation. Comprehensive explanation. You can't compare with a model. I'm sure you're able to see to come up with differences between a theory and a model. And then example of a theory. So we have electromagnetic theory. Electromagnetic theory. And some of you, I'm sure you had issues with electromagnetic theory because this topic is under physics and it's in grade 12. A lot of grade 12 face challenges challenges on this because I'm a teacher. I understand. You get? Because it's why do they fail to understand this? Because it contains comprehensive data, comprehensive explanation. You get? Now, let's go to an example that will help us understand is this, which is electromagnetic theory. So imagine a scientist, they discovered wavelength, which is lambda. I'm sure you remember wavelength. You used to solve this. Now imagine for someone to come up with wavelength. How did they come up with this same thing called wavelength? There were some theories. I'm sure you have been thinking. You get? It's because it has to undergo repeated what experiments, and then this same electromagnetic theory, it talks about the wavelength. Apart from that, the propagation direction of a wave. Now, for you to know the direction of a wave, it must it must be something that should uh, involve repeated what experiments for you to understand the electric field. Have you seen? So for you to understand all this, whatever is happening here, it requires repeated what experiments. So I've just put this to make you understand. For someone to come up with the direction of a wave, how did they come up with it? For someone to come up with the electric field, how did they come up with it? For the wavelengths, how did they come up with it? Because of the theory. You get? Because of repeated what experiments. Hope that is clear. Now let's go to before we go to that, there's this important point. A theory explains why phenomena occur, why that thing occur. You get why something is occurring. I'm sure you can remember this. Apart from that, let's look at laws. What's a law? What do you have to understand about it? So a law now is a concise statement. Now, this one is just a statement. This one is just a statement, often mathematical. Have you seen? It's mathematical. Describing a what? A relationship. So a law is just therefore to describe a relationship. And it must be a concise what? Statement, which should be in mathematical form, describing a certain what? Relationship. An example, as you know, just Newton's second law, which is this, the one we talked about. So this is just a statement. This is just a statement, a concise statement, mathematically describing what? A relationship um that is between this, that is on force, mass, and what? Acceleration. There's a certain relationship here, as I explained. Apart from that, we need to know that laws describe what happens, not why. Theories explain why. You get? But laws describe what happens, not why. Hope that is clear. Now, interesting part. Before I go to the other part, is there any question on Newton's theories and laws? Hello? Hmm. Okay, so everything is clear. I even thought I almost thought that you guys are logged out. So please respond fast. Respond fast. So I wanted to check. I might find that maybe people are logged out due to network. Thank you. So now let's go to measurement and uncertainty. This is a part that I want you to understand, and it's the last part. So now measurement and uncertainty. So now, what do you understand by measurement? So a measurement is comparing a quantity with standard unit, comparing quantity with standard unit. Example, length measured using a meter law. As you can see, this is being measured. Now, the key part under measuring, we are comparing this to a standard unit. So comparing a quantity with what? Standard unit. Guys, what can happen if we didn't have standard units around the world? I'm sure there would have been a confusion. Imagine we have some architectures, they helps us to design something. Before they design anything, even me, I can text them if I want to come up with maybe with a university, I want to build or construct a university. I can inbox maybe international architectures. I would say, Zambia, I would say, okay, in Zambia, we don't have power of architecture. So let me inbox someone abroad, you get? And then those architectures, they will require measurements, you get, of something that I want to come up with. They will ask. And the measurements that I'm going to come up with, when I share with them, it will suit because we have standard unit. the standard units. So we have the meter law, and we have so many things that are used to measure things. So the standard unit. So it's also about comparing a quantity with a what? Standard what unit. So as you can see, this pencil is being measured using the standard units. Hope that is clear. Let's go to uncertainty. Uncertainty. What do you understand by uncertainty? Or what do you have to know about it? Uncertainty. Just call it uncertainty. It's not certain, but uncertain. So no measurement is exact. You need to know that no measurement is exact. No measurement is exact. Sources of uncertainty. Why? Explaining why. No measurements are exact, but why? Sources. What makes measurements not to be exact? The first one is instrument limitations. It can be the instrument is not giving exact measurements. You get? Apart from that, it can also be human errors. Human errors. You get? That can make the measurement not to be exact. So uncertainty, no measurement is exact. Please master this. Under this part, I want you to be mastering concepts because we use this. They have some tasks for you. So uncertainty, no measurement is exact. Sources, what can make measurement not to be exact? Instrument limitation, the same instrument which is used for measuring, it's having some issues. Human errors, you get? Example. We are having this. You get? Have you seen? This is your measurement. This is your measurement. This is length. It's represented by 1.25 plus or minus 0 0.1 meter. What does this mean? Plus or minus. What does this mean? We're saying no measurement is exact. That's the reason why they have included plus or minus. So there is a relationship. So this means that the true value lies between 1.24 meter and 1.26 meter. You get? So it's like just like this plus or minus. When you add 0.01, you're going to get 1.6 meter. When you subtract 0.01 from 1.5, you'll get what? 1.2 meter. So which means the true value lies between 1.24 meter and 1.26. Is there any question before I proceed on this part? I'm sure you're able to understand the plus or minus because we're saying no measurement is exact. So that's the reason why they include plus or minus. Yes. Okay. So here, imagine you measure something. These are errors. 0.01. You remember Venus when measuring. Yes, because of human errors or limitations. Because of maybe you didn't clean the instrument. You didn't clean the instrument. You get? So the instrument itself, it's having 0.01. It's adding something to your measurement. So that's the reason why I add in plus or minus. So this means the true value, very good. So the true value lies between 1.24 meter and 1. I hope that is clear. Let me just. Now, accuracy versus precision. You need to know this. What's accuracy? So accuracy, how close a measurement is to the true value now, to the true value. How close a measurement is to the true value. That's accuracy. I'll be asking you this. Don't forget this. What is accuracy? So how close a measurement is to the true value. Close to the true value. Because we said uncertainty was explaining no measurement is exact. So now, when you talk of accuracy, we're just trying to talk about how close a measurement is to the true value. Now let's look at precision. Precision talks about how close repeated measurements are to each other. Have you seen? Accuracy and precision are not the same, are different. So precision, how close repeated measurements. You find that you can measure something several times but still not get the exact measurement. You get? You find that you do this measurement, you get 1.2, you do again the same measurement, you get maybe 1.3, just like that. So now how close repeated measurements are to each other. So I'll make you understand this, don't forget. But just note that accuracy and precision are not the same. Now, example. For example, you're having the true value is this. This is the true value, guys. This is the true value of a measurement, which is 5.0 centimeter. Now, from that, what else do you have to know? How can you explain this using accuracy and precision? How can you explain this using accuracy and precision? So, before that, let's do this explanation. The first one. Mhm. So, example. This is the true value. So you're conducting an experiment. You're trying to measure this. The first, when you measure the first time, you get 5.01. You measure the second time, you get 5.00. You measure the third time, you get 4.99 due to human errors and whatsoever. Now, how can you interpret this information? Have you seen? You're trying to compare this with the true value. How can you explain this in terms of accuracy and precision? So we can say the interpretation is accurate and precise. This is accurate and precise. Why? Because 5.01 is close to the true value. 5 point, it is even the exact one. You get? And then 4.99, if you're even to round it off, it can give you that. So we can conclude that these results or measurements are accurate and precise. You get? So accurate, which means they are how close the measurement is to the true value. So they are close to the true value. Now, under precise, what can we say? How close repeated measurements are to each other. They are close, okay? Repeated measurements are to each other. They are close. So therefore, this information we can say it's accurate and precise. Hope that is clear. Now let's go to the other one. What about this? For example, now the other time you measure this is a true value. Now you measure the first time, you get 4.55. You're trying to come up with this same centimeter. This is a true value. You get 4.50. You measure the second time, you get this same one. You measure the third time, you get this same one. Now, when you compare this measurement to the true value, before we go to that, in terms of how can you interpret this? So this information is precise. What does it mean precise? So the repeated measurements, according to this, it's precise. They are repeated. They are close. How close repeated measurements are to each other. So yes, they are precise. They are repeated, but not what? Accurate. Is this accurate? No. Compare it to the true value. Is 4 point close to that? So this information is not accurate, but it's precise. There is that closeness in terms of the measurement. Is it clear before I proceed to the other part? Thank you so much. So you need to understand the relationship that is between accuracy and precision. Apart from that, this is the part that I want you to understand, guys. I'm happy that I'm about to be done. This is the last part, so just take heart. We'll be done soon. So significant figures. This won't be that tricky because you guys, you know this. Yeah. So now, significant figures. What you have to know indicate precision of a measurement, not its accuracy. Have you seen significant figures? Indicate precision. I'm sure you understand now what precision is. So indicate precision of a measurement, not its what? Accuracy. Now, the loose for significant figures. What are the loose for significant figures? One, non-zero digits are significant. Zero digits are significant. E.g., you can have 4, 3, 5. What's a significant figure for this? If you remember, so these are non-zero numbers. So we can say here 1, 2, 3. So that's we have three significant what? Figures. Is it clear? So those are loose. Exactly. So non-zero digits are significant. So these are not having zeros. Then so we can conclude that this is having how many significant figures? I didn't even get. So that's three. Sorry. Three significant figures. Then let's go to the other one. Mute your mic. Whoever is having the mic on, please, please, please mute your mics. Mute your mics. Mute your mic. Mute your mic. Thank you. Then the other two, zeros between non-zero digits are significant. What does it mean? So it means this. You get? So these are zeros between non-zero digits. You get? So these are significant. We can count this also. So that's having four significant what? Figures. Yes. The other law is leading zeros. Leading zeros are not significant. E.g., leading zeros like 0.012. How many significant figures are here? Very good. That's two significant figures. The zeros, the leading zeros are not what? Significant. Thank you. And let's go to the trailing zeros after a decimal are significant. Trailing zeros after the decimal are significant. E.g., um, you can have 2.00. What can be the significant the number of significant figures here? Yes, three. So there's yes, the trailing zeros after. Yes, so that's three significant figures. Thank you. So let's go to this part now. This is a part that I want you to understand. Calculations involving several numbers. Mhm. Yes, explain more. Okay, let me explain. Significant figures quickly. So the first clue, if you can remember, we are saying non-zero digits are significant. Non-zero digits, things that are not having a zero. For example, 4, 3, 2. These are significant. You can count this as your measurement. So physics is very much important. Have you seen? It helps you to understand the numbers, the measurements in construction. For construction, this is very much important. So here we can say we have three significant what figures, significant figures. You get? That's what this rule, first rule means. All the digits which are not having a zero, you can count those numbers in short, which means the numbers are significant. Now, let's go to the other rule. Zeros between non-zero digits. Zeros between non-zero digits are significant. So for example, we are saying in front, we are going to have non-zero digits. Like maybe you can have 4.005, like that. We're saying these zeros, since because they're in between the non-zero digits, these numbers which are not having zeros, we can count also this. We can say we're having how many significant figures here? 4. 1, 2, 3, 4. So this is 4 significant figures. Clear? Yes. And then the other one is leading zeros. Leading zeros are not significant. Leading zeros are not significant. So leading zeros, what does it mean, leading? Which means the zero should be, if the zero is in front, like 0.024, don't count these zeros in front. They are not significant. So here we can just conclude to say we're having how many? Two significant what? Figures. Let's go to 0 point 0.2, 0.2, 0 point, or 0.0. Mm, mm, thank you. Here Who can try first before I answer this? How many significant figures are here? Yes, yes. And then this zero is significant because it's satisfying with this second rule. We said zeros between non-significant figures are what? Significant. So here we're counting also this zero because it's in between 2 and 3, which are non-zeros. Thank you. So here it's 3. Thank you so much. Thank you so much, guys. So let's go to the last one. Yeah, trading. Oh, I've explained the last one, huh? This now let's go to this. This is the part I want you to understand, guys. Without wasting much of the time, we are done. So let me just explain this last part. So now in case of multiplication and division, I want you to pay extra attention now. Here, the homework that I'll give you is you need to come up with a law. You explain the law. I'll give you just answers I will solve, but you come up with a law that will make you understand or solve questions that I have for you. So now, what do you understand about multiplication and division? In case you're multiplying two numbers or you're dividing two numbers, you come up with measurements. Since we said under uncertainty to say no measurement is exact, you come up with two numbers, but you just want to come up with one. What can happen? So here, under multiplication, know that answer as the same number of significant figures as the least precise quantity. Here I will explain. Don't worry about anything I will explain. Don't worry, I'll make you understand this later on. For example, this I want to explain. Let me put it here. So for example, you take the measurement. Your measurement is you're having sorry, your measurement you're having 2.34 as your measurement, the first one you have, and then there is this which is having 0.01. You have two measurements here. This close bracket means multiplication. Since here we're dealing with multiplication, multiplied by 0.100. So now here we just want to come up with a significant figure. We're having two numbers. We just want to come up with one answer. What does this mean? How can we come up with the answer? So on this one, what we do is, how many significant figures is this having? The first one, this number. Very good. Then the other one, how many? Very good. So now this, yes. So whenever you're multiplying or dividing, the answer has the same number of significant figures. So the answer that we're going to get as we multiply should have the same number of significant figures as the least precise quantity. So I'll explain this list later on. So now, when you multiply these two, what are you getting? Yeah. So multiply 2.3. We're having what? 0. The answer is there. It's 0.234. So now, how many significant figures are here? Yes. So it's satisfying. You get? So we're saying the answer has the same number of what? Significant figures. Now, there are situations. So there are situations whereby you're having a different one. For example, now you're having, I'll explain this, don't worry. You're having 4.56 multiplied by 1.2. So now here, how many significant figures are you having here? Very good. So we have three significant figures. We have three significant figures. Now, what about this here, this one here? Very good. Two significant figures. Very good. Now here, it's different. Here we are having 3. So the answer is just direct 3. So if it's the same, continue. Now, if it's different, go for the least precise. Least precise, the one which is having the smaller values. You get? So I'm going for 2. My answer should have 2. After multiplying, my answer should have 2 significant figures as the answer. We don't consider the more precise, the one which is having greater numbers. We consider the one which is having lower numbers. You get? So here, when we multiply 4. when we multiply 4.56 times 1.25, we're going to get 5.472. Now, when we get this, what will determine the answer of this is the one which is having the least precise. This we can say the least precise, which means it's having the less, it's having lower numbers or lower values. You get? It's having lower numbers. It's having lower numbers, as you can see. So, as a number of figures. So, this is what we're calling the less precise. So, this determines the answer that you get. So, here, now we are having how many significant figures are here? There are four, not so. So, yes, because of this, the one least precise, we are going to round off. 7 will give this to become what? 5.5. So that's our answer. Is it clear? And the answer, this one is having two significant what? Figures. So we consider the least precise. In a case you're having different significant figures as you're multiplying, you consider the one which is least. Okay, so let's go now to yes. The same law applies to division. For example, we are dividing. Here, we are dividing 6.3. Okay, let me just write it somewhere there on top. 6.30 and divided by 0.45. When you divide, okay, before dividing, what's the number of significant figures here on top? That's 3, not so. Down there, we're having what? Down we're having what? Very good. 2. Down we're having 2. So now, which one is the least precise here? Yes, which is this one? Yes, the one which, so we are going to consider it. So we are not following that because of it's having more precise. Yes, so we're considering the least precise. So which is 2, the one which is giving us lower values or lower numbers. So now this one. So we know that our answer, when we divide, it's going to give us what? It's giving something like 14. And this 14, how many significant numbers, significant figures are here? 2. Very good. So have you seen? It's matching with the least precise 2. This thing is done. Then let's go to the last one, subtraction. So have you seen? The other thing that I want you to note or to take note is for multiplication and division, we consider significant figures. We consider significant figures, but for addition and subtraction, it's a decimal point. I'll make you understand. Decimal place, the decimal place. I'll make you understand. Don't worry. So now, under addition and subtraction is something different, but the concept is somehow the same. So the answer has the same number of what? Decimal places. So this one is now dependent on the decimal place. Addition and subtraction is dependent on the decimal place. And then for division and multiplication, significant figures. Don't forget that. So now, example. We're having this. Guys, we're adding. Everything. As you are adding 12.11 plus 0.3, it's giving us what? Before that, what's the number of decimal? This one we are considering the decimal. How many decimal places are here? How many decimal places are here? 2. After the decimal, when you count in 1, 2, we're having 2. So here we're having 2 decimal. 2 decimal. Then here, how many decimal places are after the decimal? What number is here? It's 1, not so. So which one is the least precise here? 0.3. Very good. Yes, 0.3. So we know that our answer, the final answer should have one decimal place too after adding. So we'll add. So this plus that is going to give us 12.41. It's going to give us 12.41. Then our final answer will be what? We'll get rid of the 1. It will be just 12.4. Then we are done. Clear? Okay, so the same concept. Oh, I repeat. So as we okay, yes, okay, I'm repeating now. So I'm saying if we are to add now, like 12.11 plus 0.3, before you do anything, addition and subtraction, we consider the decimal places. First, look for the decimal places. How many decimal places is this first part having? 12.111. After the decimal place, how many numbers? So two decimal place. Then let's look at 0.3. How many decimal places are here? It's one, not so. Very good. So we're having one. So now, which one is the least precise? My question is, which one is the least precise? Very good. This one, 0.3. So meaning our answer after adding this, our answer after adding should have one decimal place also. So we won't consider anything that is having after adding. We'll consider the one which is having one decimal place. So after adding, we're getting what? 12.41. After adding this, what are we supposed to do here now? We know that our answer should have what? One decimal place. So our final answer, will get rid of that one, then it will be 12.4 as the answer. Are you clear now before I proceed to the other part? Yes. Why are we not adding one? Can someone explain? Why are we not adding one? Can someone explain the reason why we're not adding one? If you guys can remember. Yes, yes, that's the answer. All numbers, yes. We can only add if at all we add 5, 6, 7. But any number less than 5, like 4, 3, 2, 1, we don't add anything to that. Hope that is clear. Thank you for that observation. And then this one I want to solve. I'm sure I've explained and you're able to see. How many decimal places are here? Two, not? Here we have also. Here we have one, not? After add, so this one is the least precise. You are following that. So our answer should have one decimal place. So after adding, oh, so this is subtraction. After subtracting, they had to get that, and they had to get rid of that too because of what? It's less than 5. Less than or equal to 5. You get? Thank you. Let's go to this is your task. So I want you to answer this task and submit this via my WhatsApp number. I want you now to state the laws for this. So the first one, state the law for significant figures. For multiplication, there's a law that I was using, though I didn't explain much about the law, but there's the law that is governing that, of which you can't fail that. For multiplication and division, it's having the same law. State the law for significant figures in addition and subtraction, of which you do that. And there is this question. A student measures the length of a wire, which is having this measurement there, and the diameter is this. State the number of significant figures in each measurement. Can you feel that? Explain why significant figures are important in scientific measurements. Why is this important? You need to explain that. The other one is this that I want you to do now. You need to calculate this and give your answer to the correct number of what? Decimal places. Apart from that, I have this question for you that you need to answer and submit. Are you guys still part of class? Are these questions hard for you? Or you can, yes, and when, yes, you answer, and then when answering, please indicate the numbers. You can say question 1A, question 1B, question 4, just like that. And then let's do the quiz now. We are answering this together. Just want to see if you guys understood or not. Physics is best described as the study of what? Physics is best explained as the study of what? A, living organisms only. B, chemicals and reactions. C, matter, energy, and their interactions. D, planets and stars only. Sorry. What's the answer there? The answer is C. How many are saying the answer is C? All of you are saying C? Okay, that's good. You guys understood. So matter, energy, and interactions. Then question two, which of the following shows that physics is fundamental science? Which of the following shows that physics is fundamental? A, it studies living systems. B, it explains basic principles used in other sciences. C, it replaces chemistry and biology. D, it deals only with machines. So which one can be the answer here? Very good. So you guys understood. Thank you. Let's go to question three. The aim of physics is to, what's the aim for physics? A, memorize formulas. B, discover universal laws of nature. C, classify substances. D, study only laboratory experiments. What do you think can be the answer here? Very good. So discover universal laws. Thank you. Question four. Which of the following is not a step in scientific method? Which one is not a step in scientific method? I want to see if you guys are able to remember. A, observation. B, hypothesis. C, assumption. D, experiment. Which one can be the answer here? Uh, very good. So which one is missing if you're able to remember? Yes, this is correct. Which one is missing? Theories and laws, huh? Or theories or laws. Thank you so much. Thank you so much. You guys, you have gotten the concept. Now, question five. Physics laws are expressed mathematically mainly because mathematics A makes physics complicated, B allows precise predictions, C replaces experiments, D is easier to remember. What can be the answer here? Very good. Allows precise predictions. So you guys, this is what I had for you, and I'm sure you guys enjoyed and understood. This is the foundation you need. And before we can go any further, this should be the next thing that we're supposed to do. For those who started paying, some have paid, and of which this is the next part that I want you to understand. You need to have a proper foundation for your physics. You need to shine. For that applies. So we'll look at this in the next video or class for those who are doing tuitions with me, those who are starting tonight, or those who are paying tonight, or those who are interested. So this is what I want you to understand, very much important. And we'll look at the dimension analysis. Here, that's where now physics starts in terms of, I want to show you how to check. I'll make you understand this. So please ensure that you see or you talk to Mr. Timothy concerning tuitions. Inbox him. For those who are interested, inbox him. I just want a limited number because of some issues. I want a number that I can manage in terms of marking and everything because I have a lot. So please, for those who are interested, inbox Mr. Timothy, and Mr. Timothy will direct you on how to go about online classes. And you'll be added in the group. Immediately as you pay, you'll be added into the group. The timetable will be shared to you guys. And I can assure you, with me, an A plus is guaranteed. If you want physics or if you want to do medicine